Hey students, I'm in Copenhagen and I'm standing in front of the Rundetaarn, or the Round Tower, which is the oldest functioning observatory in Europe. It was built in the 1640s by a it was built to be a successor to Tycho Brahe's observatory. And it was built under the supervision of a guy who had been Tycho Brahe's assistant, a guy named Longomontanus. The top of the observatory would have had various instruments like Tycho Brahe's and probably telescopes as well. If you could zoom it up onto the dome on the top. The dome there is a later addition. I'm not sure when it was put on. That's from a later time. And then if you take a look, you'll notice the tower is built attached to this large church here, which is Trinity Lutheran Church. And this kind of brings us to one of the questions that one of our people in the fall 2014 astronomy class asked, which is, she asked in the questions you all submitted, why not keep the science and the religions separate? Why are they always sort of mentioned together in our studies? And the answer to that question is that the people who we are studying did not keep them separate. Aristotle, Copernicus, and numerous other people who we will run into did not. That's not how they viewed things. The idea that these two things should be sort of separate worlds, that's a relatively recent idea. And that goes back to whether we go to our really early supernatural view of the universe, in which the universe was viewed as actually being gods and goddesses that are doing things in the world, or if we get later to the sort of period we're studying now, or even sort of Aristotle's view, is that the universe runs on these fixed rules. It's not run by the direct whim of some spirit, but nonetheless they view the rules as being the action of God. So Copernicus describes the universe as the great work of the best and greatest artist. So if we want to understand how we know what we know about science, well, that's going to be intertwined with these guys' discussions of religion, because that's how they viewed the universe. And so that's part of the story. All right. Howdy, we're inside the Round Tower, and of course the tower is built right onto the side of the Lutheran Church here. It's just a big spiral going up to the observatory on top of the tower. Supposedly you can take horses and someone wants to go with a car. This is up on top of the tower. There's the observatory dome. There's the roof of the church that we're sitting up on top of, Trinity Lutheran, and the skyline of Copenhagen. We're back inside the tower, and what's up here on the ceiling is a mechanical solar system model. And it has, let's see if I can do the zoom right on this. This is a Copernican system. There's the sun, and Mercury, and Venus, and the Earth is there. And backing out, Mars. And let's see, there's Saturn, there's Jupiter. So, that's the solar system. It does not show outer planets. This one is a replacement for one that was originally put here and built back in the 1600s. And that one, the guide says, showed both the Copernican model of the solar system and the Tychonic model, because in the 1600s they didn't know which of those was correct, Copernican or Tychonic. Now that it's there, replaced in 1928, well, they knew it was the Copernican. They knew the Copernican system was right there. So I got to get out of the way because there's a bunch of tourists coming down through the room. That used to have both the Copernican and the Tychonic system, the heliocentric and geocentric. It brings up a good point to address another excellent question that one of the students in class asked, and that was, hey, isn't so the problem with the Copernican system is these huge distances and these huge stars? Couldn't the Copernicans turn around and say, well, listen, those real fast-moving stars in the geocentric system are just as big of a problem as the giant stars in the Copernican system? And that's an excellent question, because that's exactly the objection that was raised by the Copernicans to counter the problem of the giant stars in their system. This is the outside of the tower. And so the observatory up there. And I can't quite make out what that says. This question of the Tychonic versus the Copernican theories, and our student's very excellent question about the speed of the stars going around the Earth in any geocentric theory, including the Tychonic theory, versus the Tychonic's objection that, hey, in the Copernican theory, the stars are a huge distance away, and they're all giant. They're totally dwarfing the sun, dwarfing the solar system. How was that resolved? And what the Tychonics said back was, look, the speed of the stars going around the Earth is not actually a problem. Okay, what their response was is anything that goes in a circle in a 24-hour period, whether it's, if you say the Earth is going in a circle in the Copernican theory, rotating around itself every 24 hours, or if you're in the Tychonic theory and you say that the stars are going around the Earth every 24 hours, what in particular Giovanni Battista Riccioli had to say about this, and he's covered in chapter 10, is that, look, anything that rotates once every 24 hours essentially is going through one circumference per day. Earth goes through one circumference per day if it's turning, stars go through one circumference per day if they're turning, so that as a sphere or as a rotation, the rate is the same. And that the only reason we find the speeds different is because of our individual size. So Riccioli said something to the effect of, an ant would think that a human being walking is going incredibly fast because it would take an ant much longer to cover that same distance. But that doesn't mean that we as humans are going fast, because for us, it's just not that great of a speed. You know, the ants think it's fast because we're very small. So what Riccioli said is, whether you look at the Earth is turning or the stars is turning, in terms of their own radius, the radius of the object that is doing the turning, it's the same. What you see here is essentially an astronomical facility, but at least built, the basics of it were built during the time period that we're talking about in class. And we're not actually at Tycho's location of his observatory, but this is in an area that was doing astronomical research at the time that we've been discussing in class. All right, one last look at the Rundetaarn here. And of course, if we're going to be at an old astronomical facility in Denmark, where they're going to have a statue of the great man himself,